Okay, thank you, Galen. Thank you, everybody who is joining us here today. And thank everybody for muting their mics if they're not talking. So I'm going to get right to it, and I'm going to introduce Dr. Thomas Hayes, who is forgive me, Dr. Hayes, if I mess this up. You are the professor, instructor, the head honcho of the OU Capstone project. And I'm just going to turn it over to you, let you introduce your crew there, and tell us what kind of good stuff that's been going on over there. So, Dr. Hayes, you have the com.
Oh, sure. Yeah, I'm happy to present to you guys today Eric, Vince, and Amber. They've been working on a high altitude balloon project this spring semester as part of Aerospace Capstone. So, I'm the professor of practice for aerospace engineering at OU. And as part of that, I get to work with all the senior engineers on interesting projects. And in the past couple of years, starting with the technician license I got for high altitude rocketry work, it's grown into more and more of an amateur radio obsession and interest. And now we actually start teaching some RF topics to aerospace engineers in aerospace capstone so they can better understand how to integrate with RF scientists, integrate antennas onto aircraft, radar systems onto aircraft. And while they may not be experts in the discipline and certainly not electrical engineers, the fact they know a little bit helps them go a long way to differentiate themselves from other aerospace graduates from around the country. So yeah, we have students now talking about, ultra low frequency communication with submarines and of course, we have to stay a little bit away from RCS topics and ideas like that because of the military classified nature of them. But in terms of communications and integration of RF systems onto vehicles, it's a really great project. This project you're going to hear about today, the high altitude balloon, which I'll let the students do the explaining. They're actually here to present to you themselves, which is basically middle of the night for college students, I think. They're going to go through their super pressure high altitude balloon, which they've launched a number of, and just I don't want to steal their thunder because some of the ranges and power levels they've been using are just really, really astounding. I do want to very much thank SCARS, especially Mark Klein, Peter Laws, and Peter Core for assisting out with the group. Mark has been, as we all know, a phenomenal resource for the students. He has such a mind for helping them. So thank you so much, Mark. He met with them every Monday of the whole semester. So thank you so much for your time spent with the students. Someday, hopefully, we all can pay you back for your dedication. So, so credit goes to Mark as well in the success the students have had here. I guess, Mark, do you have anything you want to say, or do we turn it straight over to the students to see their presentation?
I don't know if they're going to bring it up, but Tom Medlin, are they going to bring that up? Do you know?
I'm not sure, but it's also to give credit to Tom Medlin, who's W5KUB. He's launched a number of these balloons and is kind of the expert global, worldwide high altitude balloon launcher that has also dropped into a few meetings and has assisted the students greatly in developing their habits, developing software, looking at some of the math required for determining altitude, even sharing spreadsheets and coming in to talk with the students themselves. So yes, thank you, Mark, for helping me avoid that lapse of mention, because Tom certainly also deserves credit for all the help he's given the students.
It's a lot of fun.
So with that, I think, Vince, I saw in Slack that you're going to be screen sharing. So if you want to go right ahead, I think you guys can go with your presentation.
I just want to say thanks to Mark and Dr. Hayes. And then I know Tom isn't here, but yeah, we really couldn't have gotten this far without y'all three. Just having to learn all radio. We three of us got general license and one of us got technicians. And I would have never thought I would have gotten those before this semester. It was really fun, passing all the tests and everything. So it was really exciting. But we're just going to show our capstone video, and then I'm going to give an updated slide because we're still working on. We still have one more launch that we're going to try to do before the end of the semester. We're kind of just waiting on good weather, and then we can just open up to questions. So let me share my screen.
Don't forget your audio.
Are you able to see it?
Yes, it looks good.
Let's make sure that's all the way up. Okay, there we go. Hi, today we'll be going over the OU Aero Satellite Capstone project. So our mission overview was to design, build, and launch at least 4 high-altitude balloons that were as light as possible and that would stay up for as long as possible. These balloons have transmitters on them that transmit their location, altitude, speed, temperature, voltage, and ambient pressure.
Our schedule was laid out in a quantifiable way to ensure the goal was not too hard to reach, but it also allowed us to challenge ourselves enough. We quantified this in the amount of pico balloons launched. Due to weather, it was an uncertainty that we could launch on certain days, so we designated it as also ready to go. It should also be noted that the entire group obtained their licensing after the first drop dead date, so we could use our own call signs legally. The first launch was utilized using the university's call sign. In the beginning month or so, we were all getting a hold of radio and understanding it and how it applied to pico balloons, so by the next month we felt comfortable enough and took the amateur radio test for our second launch. So February 26th, we wanted a fully functional pico balloon with a tracker and all the necessary components for power and lift. By March 26th, we wanted to have one more additional pico balloon launched by then, so 2 in total. April 23rd, that's technically not a drop dead date, but it's more of a end of semester goal so that we can reach that and feel fulfilled. And by the end, we had wished to have 4 pico balloons launched to succeed.
At the beginning of our design approach, we knew we wanted to maximize our cruising altitude. This is because typically clouds are between 10 to 20,000 feet, and storm clouds will get up to about 60,000 feet, but we know we can't get around these, but at least we can get around the 10 to 20,000 feet clouds. So to do this, we knew that we needed to minimize our weight. As you can see from our graph on the right, the altitude of the balloon depends heavily on the mass of the payload. And as you increase the mass of the payload, the cruising altitude of the balloon will decrease. We also wanted to minimize our number of parts. This is because we wanted to keep it extremely simple. We wanted to decrease the number of reasons why it could fail, and decreasing the number of parts can also save quite a bit of weight overall. We also wanted to make sure that our structures could withstand the turbulent winds seen up at about 40,000 feet, 30,000 feet, which can get up to about 120 miles an hour, 150. We needed to make sure that it could withstand the low temperatures, which is about negative 40 degrees Celsius, and the high radiation seen at that altitude. We also wanted to make sure that our solar panels could supply the correct voltage and current required for our tracker to transmit. To find our cruising altitude, we used the van der Waals equation as seen on the right. This equation would give us our cruising altitude, but it would also give us the overpressure seen inside the balloon. This is extremely important to know because we need to make sure that our balloon is not going to pop once it reaches its cruising altitude.
Ultimately, we used 2 balloon configurations throughout our launches, the first being the SBS-13, which is a high-quality scientific balloon designed specifically for superpressure, and if you use hydrogen, that's around the 40,000 foot range is what we got. We believe this balloon did very well for us in terms of quality of launches. We did not suspect any leakage from this balloon on the majority of the flights, and instead we ran into many spring storms that likely took down our trackers. Once we ran out of the SBS-13 balloons, we started using the 36-inch balloons. These are just cheap Chinese balloons, and in a launch we used 2 of these, and they had a significant difference in height of about 10,000 feet or so. The tracker we used in all of our launches was the light APRS made by QRP Labs. For the version that included Whisper, which is what we used, it was about $115 pre-tax for each tracker. It weighed an impressive 9 grams approximately, which was jam-packed with utilities such as tracking via Whisper and APRS. So Whisper was a protocol that allowed for weak signal radio communication between amateur radio operators, and in our case it gives a grid square location, which is about 70 by 100 miles, which also corresponds to 1 degree latitude by 2 degrees longitude. In contrast, APRS on the tracker is a radio system that allowed for real-time digital information such as altitude, location, temperature, pressure, height, and also battery voltage and other telemetry. So to do this, it would send out bursts of power using our supercapacitors that were charged up from the solar panel, of up to 1 watt of power, whereas the Whisper just did around 10 milliwatts. All of this was readily assembled on a printed circuit board and was used with open source software that we could change via USB.
About the solar panel, we used NPT675 panel for the first prototype. The solar panel is thin, light, and flexible. Signal board only uses 3.3 volts to operate. After the first launch, we switched to using NPT475 panels to reduce weight and make the system less bulky. Here is our final system design. The tracker is powered by one NPT475 solar panel and two 3-volt 2-farad supercapacitors connected in series. On the bottom of the tracker, there are two antenna wires. One is 20 meter long for 20 meter band in Whisper mode. The other is 19-inch long for 2 meter band in APRS mode. On the top of the tracker, there is one 20 meter long ground antenna wire. The whole system weighs less than an ounce, around 24 grams to be specific. The payload is tied below balloon using friction wire. For the first 3 launches, we used SBS-13 balloon to carry the payload, and for the 4th launch, we switched to using two 36-inch foil balloons instead. These balloons were filled with hydrogen, except for the first launch, we used helium. The amount of gas was filled just enough to lift the balloon to around 40,000 feet. After reaching that floating altitude, they continued to stay aloft and fly without bursting. The tracker showed on the right is the latest tracker version that has flown in the mission. The mass of this tracker was considered and minimized to every gram. We minimized the mass of this tracker by selecting the lightest solar panels, capacitors, wires, and strings that we could find. We even used a bamboo stick to connect the solar panel to the board since this material is light enough and can structurally support the tracker against high winds. This is the lightest tracker version. It weighs only 16.66 grams.
Our first launch was on March 6th. We used helium as the lifting gas and the SBS-13 balloon. The launch was successful, reaching an altitude of around 30,000 feet. We lost contact with the balloon the next day, and we believe that the failure was either due to a condensation buildup or mishandling of the material. This first launch proved that the tracker was able to be detected long and wide, being detected from even Australia. And on the right we have a picture of the balloon flying up. Now, to determine the possible failure states of the balloon, we narrowed down by taking the tracker, having it run through the night, and seeing if it's running the next day. And we did this test, and it turns out it was working the next day, so it was unlikely that it was the capacitors or solar panel causing any failure. So the balloon likely hit a cloud or leaked helium. So we decided that for further launch, we were to take special care to make sure that the balloon did not get damaged before launch. Our second launch was on March 23rd. This used the SBS-13 balloon, but it used hydrogen as the lifting gas. The tracker, unfortunately, hit the ground before the balloon was able to lift it. This had a effect where the APRS signals were unresponsive. However, Whisper was fully available. So we were able to track it, but not with the full capability. And the result of this launch is that we figured out how to launch the balloon more successfully, taking better care to prevent the tracker from getting damaged. The third launch was on March 28th. The launch was fully successful, reaching an altitude of 42,000 feet using the SBS-13 balloon. This tracker restarted the next day and eventually condensation brought it down over Newfoundland. And we were able to determine this by seeing the altitude slowly decrease over time. Our fourth launch was launched on April 8th. Instead of the SBS-13, we used 2 foil balloons. This had a direct impact and reduced the altitude of the balloons to 30,000 feet, but it significantly reduced the cost of the balloon. And this balloon and tracker was able to reconnect the next day, but unfortunately the tracker was probably taken down by a storm vortex over the Great Lakes.
And finally, we wanted to acknowledge Mark Klein, N5HCR. He mentored our entire team through this whole process. He knows everything about amateur radio. He helped us pass our test. Anything you want to know about amateur radio, he knows. And then we also wanted to thank the SCARS Radio Society, W5NOR. They also helped us immensely through our process, and we really couldn't have done it without them. And that concludes our presentation. Thank you for watching. Alright, so that's the end of the video, but I can also give a new update. So this is our current balloon we've been working on. It's about 16 feet long. It has a volume of estimated 180 cubic feet. It shows that it's supposed to be like 220, but we're unsure about how when it fills up. It's not we kind of estimated it off a cylinder, and we estimated that it's not a perfect cylinder, so we said it was about 180, and this would put us about at 64,000 feet. And here it's laying on 2 tables, and then this is a couple days ago when we inflated it, but we're kind of having issues with our sealing, or we're not. When we got the product, we noticed that there's kind of these like little tiny like micro holes in it. So we patched every one that we could see, and it holds air initially and it looks great, but after 2 or 3 hours of it being pressurized, it slowly leaks out. So it's kind of an issue for us when we're trying to make it last for months on end. And yeah, I think that's the end of our little presentation. We can go over questions.
I think it's an awesome project. Thank you very much for sharing that. What Tom Medlin, I know, is doing a super balloon kind of idea thing, like just like this. He's finding the same thing with these micro holes. He actually got his on his garage floor, and he's seeing the sand particles eat away at that material. What thickness are you talking about on that stuff? And have you found anything that may keep it alive in the air?
This material is 1 mil. And when we were handling the balloon, like, okay, currently this is in our living room, but this is after multiple tests where it just kept on deflating. So we're like, we need to get a photo of it when it's filled for this presentation. And also because it just looks cool. Like his head's right here and this thing's huge. But when we were handling it, we always had tarps down. We always had, it wasn't going to touch anything that we thought would poke it. But also we took some of our excess material and we took a pin and tried to pierce it, and it wouldn't even pierce. So that's what I was kind of confused about. That Tom was saying that sand and like little things in his garage were puncturing it, but if I was having an issue getting a pin through it, then I don't think that a piece of sand would. So I'm really unsure. We triple checked our seals. We went over, then we even decreased the size of inside the balloon to create about 6 inches worth of seal, because we just wanted to make it work. And we just, I don't know if it's just snaking out one of those seals, because we just take the 2 layers, we fold it over each other, and put a hot iron on it, and you can see little ripples, but if you do it for long enough, it should create a good seal of about 6 inches. But I'm assuming that there's one little puzzle like maze it gets out. And oh, I guess I didn't go over it. Why we went with a tube and not like a sphere, which a sphere would be optimal, was because our material was 48 inches by however long we wanted. And we wanted to minimize our number of seals because, as we're seeing, our seals are kind of an issue. And so we just took the material and spread it out as long as we could and just folded it over like a tortilla and then just did the edges and sealed it. So we have like a giant hot dog.
Why not use a weather balloon?
Do what?
Why not use a weather balloon?
So the weather balloons, they are kind of designed to go up and pop versus what we need it to do. We need it to go up and stay, and they're extremely heavy. But they make up for it because they're just trying to hit a max altitude and pop, but we're trying to get to a max altitude and stay. And I think the weight estimates for a similar size as the SBS 13 is like 300 grams versus like 119 grams. And that would be a difference of probably like 10,000 feet, somewhere in there. Cruising
Okay.
altitude.
Okay, thank you.
Also, the difference in the material of weather balloons versus the SBS and Mylar. Weather balloons will degrade in sunlight and UV. So even if you did configure one so that it float at a constant altitude, eventually it's going to pop due to UV degradation.
Oh yeah, okay, yeah, I should have said that too. But another reason why we, on this final tractor design, why we chose a bamboo, I was really thinking about 3D printing this because I feel like plastic would be like a 3D printer would make something lighter and probably stronger because you probably make a support here. But PLA and ABS tend to get hit by UV rays and they'll just kind of melt or just deteriorate over time. So that's why we had to go with wood. Also, you can't really see it right here, but there's a string right here. And we chose fishing line, but we had to choose like threaded, braided fishing line, not plastic fishing line because of the UV rays. So that was another decision we had to make.
And the fishing line, probably to make it self-destruct, is probably designed to go away with UV, right?
Mm-hmm,
Does that
probably.
make sense? I mean, I'm not a fisherman, but that would,
Yeah.
same like the weather balloon. They're designed to fail so they don't litter the society. That's a good point. I hadn't thought of that. APRS, you said that the one of the units bounced and lost the 2 meter whispers, or the 2 meter APRS signal. You think the antenna fell off, or do you have any idea what happened there?
We think that it wasn't getting enough power because the APRS mode takes quite a bit more power than the whisper mode, and it will always send out a whisper packet before the APRS. And when we were kind of doing testing of a solar panel, because when it hit the ground, a wire went around it and flipped it over. So the solar panel was completely 90 degrees to the ground. So it was perpendicular to the ground. And when we kind of did some testing outside, the max voltage it would see was about 4.5 volts, and it would charge up to that. And then it would exhaust all the capacitors and send out a whisper, and then it would turn itself off. So then it would have to recharge to even get itself back online, get a link, and then send out another whisper packet. So never got enough power to hit an APRS. I think we got 1 or 2 midday, but after that we only got whisper. And I think it was just in a very low power mode.
Now, Peter Core did some interesting antenna work and signal work. Would you be able to speak to some of that data you got back that was assembled by Peter in his whisper test setup?
Yeah, okay, so Peter, I can't remember the exact wattage he had, but his setup that he has in his backyard is like 100 times more powerful than our balloon. And our balloon in whisper mode sends it's 10 milliwatts. That's how much power it uses to send out one signal. And ours was going all the way to Australia and stuff. And when he showed us the difference between his ground unit and ours, they were extremely similar. His was slightly better, but his setup was way more expensive and had way more power to it. But it was just because we were at 40,000 feet and he's 10 feet off the ground, which height is might, kind of what Mark said.
Yep. I think he was running 2 watts, if I remember right, from a ground-based antenna. And I think what he had was the D Explorer. There's a way you can compare whisper signals, and if you derated Peter's 2 watts to the 10 milliwatts, I think the number I'm guessing, but wasn't it 12 to 14 decibels, 12 to 14 dB that signal up in the air gave him over the ground signal. So that's 2 S units, which is pretty impressive. That's a lot of signal, and you're making it to Australia.
Yeah. Oh, well, and then our next 2 launches, they were great. He kind of went over it too. But yeah, we've just been hit by weather. I guess spring isn't the best time to send one of these balloons out, because we can just watch it. This huge vortex down here. We just see the balloon get caught up in it, boom. And then we go over to this one too. And we don't have the weather thing down here, because they're trying to show the foil balloons what they look like in this specific slide. But there's just this huge vortex up here, and we saw it go over here, and then it just, oh, and then we wake up the next morning. At least we got a packet out the next morning, because we got like 1 or 2 packets out in the morning, and it was gone after that. But that was the big reason why we switched to this, is because it flies at about 64,000 feet. That's what we estimate. And the highest weather clouds go about 60,000 feet. So we were just trying to go right over. Even if we get kind of caught up in their wind below, we shouldn't get hit by any clouds, because it seems like our clouds are our biggest issue.
I have a question.
Sure.
Are you able to compensate for the condensation with the 2 balloon this time, even though you're trying to go higher?
Like if we get condensation on the balloon, would it be okay?
Right.
So we were going to give it, okay. So all of our previous launches, they have 7 grams of free lift. So that means it can get about 7 grams worth of condensation on it. And so we were planning on, but the issue with that is if you fill it with too much at the bottom, once it gets or at ground level, once it gets up, the gas keeps on expanding. And if you put too much in the beginning, it'll pop the balloons. And so that was the whole issue. So we were going to go for about 12 grams of free lift, just in case it does hit something along the way. But when you do keep adding where it has more free lift, there's a higher and higher chance that it's going to pop itself once it reaches its cruising altitude. And you're really going to be testing your seals. And so we were just going to kind of wait for a day where there's no clouds and just hope that we can get over them before any condensation can get on them.
I have a question. How do you attempt to keep the solar panel oriented towards the sunlight?
All right, so that's a good question. So on this slide, we use 1 piece of string on this, that's the ground. This hole right here, that's kind of where we're able to attach our string. And we've actually weighted this where the capacitors weighs as much as this solar panel and the stick coming out. And so when we hold it, that's where it balances. And so even if it hits some wind and stuff, it'll always just come back to that resting spot. And
oriented, but how does it keep horizontally oriented?
It's just balanced. And so I mean, it's just straight up, like the sun, it's just parallel to the ground the whole time. So anytime the wind blows it and it kind of gets off, I guess I'm kind of confused about your question a little bit.
Well, if the solar panel is oriented away from the sun, you're not going to get much.
Oh, okay. So we only transmit during the day when the sun's pretty much over the tracker the whole time. So it will turn on at about 11 a.m. and it'll go off at about 5, and then the sun angle's too low. So it stays up like this the whole time. The sun will be here, it won't work. Here it won't work, but when it's here, yeah, it's good, and it'll stay good until it gets about here, and then the sun angle's too low. So we don't orient it at all. We just keep it straight up and hope the sun hits it.
Okay, thank you.
Didn't you guys do some tests with two cells and found that was problematic?
So we did do tests with 2 solar panels because Tom, the guy that does these balloons all the time,
Midland.
he's done it a few times where the panels are angled, and that's so you can get the morning and night, you get a longer. So ours would turn on at about 11 and go away at about 5, and his would start at like 9 and go away at like 7, and he would get enough during the peak hours. But we were just trying to get it to work, I guess, at first. And that would add a bunch of weight, adding an extra solar panel. And then we had to add, I guess Eric should chime in. He kind of did all the testing on the solar panel configurations if he's here.
Yeah, sure. You able to hear me?
Yep.
Okay.
Speak up a little bit, but yep.
All right. So when I kind of went over our solar panel configuration, it was 2 solar panels. It was kind of about the same size as the one we used in testing or in our main launches, but in testing, it's about 2 cut in half is about the size we're looking at. And then we had to connect a couple diodes to that. And overall, if you add the structures to those 2 solar panels, the diodes and everything, you're looking at about maybe double the weight of what we would see with just 1 solar panel pointed 90 degrees, pretty much horizontal to the sun. So you would see better solar, you'd get better power out of it. But the main reason we would have to implement some diodes and add some extra weight is the deal with solar panels is if you have one shaded and one has exposed to light, you'll get some kind of like voltage bleed off, and you'll get current running into the cells you don't want to that are darkened, and that'll damage the cell, and eventually the whole system will kind of be corrupted, and then we end up adding somewhat of dead weight at the end of the day there. So we just stuck with the most simple design approach so we can at least get some data out first. And if we wanted to mess around further with that, we would.
So what did you learn you didn't think you were going to learn?
A lot. Well, I guess just going over our licenses and getting that was a lot of fun. I also thought it was a 20-meter band really means that the wire is like 20 meters, but we do the half dipole, so it's only 10 meters. But I guess when people would always say that to me, I never really thought that it actually meant 20 meters. just little stuff like that. I thought it was really cool how far we could get the transmissions. I think it's in this one. Yeah, we got all the way down in Australia. On our 3rd launch, we got the EU to start talking to us. I just thought it was insane how far we could get it to go. Out of 10 milliwatts of power. I thought that was crazy.
What size was your antenna wire?
So our whisper mode was 20 meters, but it was a half dipole, so just 10 meters. And then we had the APRS as the 2-meter band, but we did the half dipole, so it was 1 meter.
But what gauge wire?
Oh, it was a 36 gauge copper wire, magnet wire. And it was extremely difficult to deal with because it's pretty much as thin as your hair. And so like when you're trying to launch it in Oklahoma winds, there was several times we would get out there and you have 10 meters worth of wire trying to hold that's as thin as a hair, and the wind's blowing and then it just will snap. So we had to bring like 2 or 3 basically backups with us just in case of a snap, and we'd have to solder it out there right before the launch. And the wire was about 0.54 grams for the full 10 meters of wire. And if we would have gone to a lower gauge wire, that would have increased the weight even more, or it would have increased the weight, even more. And I even thought about doing like 30 gauge wire, but it like almost tripled the weight. So it really wasn't worth it.
What'd you do on the 2 meter?
We did. We also just went with the 36 gauge. We were thinking about doing like guitar string or a higher gauge, but we didn't really see any issues with it except for on the second launch, where we weren't getting the APRS out, but we thought that was due to power, not the wire snapping.
So what advice do you have for a team that would carry this on next year? What's the most important thing they should take away from your work here?
I think the most important thing, first of all, I think we took a little too long to get our licenses. I think that should be priority one within the first month. So I think the semester starts like, what is it, the 15th or something like that of January. And y'all do it the first Thursday of every month, right? You're
Right.
testing.
Right.
I think you should do that. That's the first thing you should do. Just study those 2 weeks as hard as you can, especially since the start of the semester. You have every class is quite a bit chill. I would work with the SBS 13s, and I would try to make your own tracker. That would be, or make your own balloon. Really focus on the balloons, because when you get in the Excel spreadsheet, you really notice that the payload, when you're already at 16 grams, the difference between 16 and 9 is about 4,000 feet, which, I mean, that's a bit, but when weather clouds that we were hitting probably are at 50,000 or 55,000, it really doesn't make a difference making your own board and all that. But really working on a balloon that can get you up to 65,000, 64,000, I think that would be the priority, because just make it bigger. But that's kind of a logistics issue, trying to fill the hydrogen. We had quite a few issues trying to figure out places to fill the hydrogen on campus, because you're filling a balloon with hydrogen that if any static hits it, it could just pop and be a news headline for OU. So that's kind of one issue I would say that they would have to figure out right at the beginning of the semester, figure out where they're going to fill it, who they need to talk to. But that's where I would send them, is making a big balloon.
Okay, I had a question.
Okay.
Okay, so not to go into too much details, and I'm not real familiar with balloon launches and such as that. So on the device itself, first, do you have to register these with the FAA? What are the legal things that you have to do? And like, if I have a house in Canada and this thing drops in my yard, do you have like a little note in there saying, hey, this is from OU Norman, Oklahoma, or such like that? So kind of briefly explain that.
There's some law that we're allowed to legally fly under. It's on Tom W5KUB's website. I can't remember what the FAA rule is, but I'm kind of unsure about when it drops. That's one thing I'm kind of unsure about. I'm going to be completely honest.
There's a problem that you can't transmit over certain countries, like I believe UK, North Korea, and Yemen.
Yep.
So the tracker actually turns off if it's above those countries. That's one of the regulation things that we had to consider.
Okay, I wondered about that because I know that you can't just fly over any place and invade their airspace. So I was kind of curious about that, but thank you for answering that.
I
And
have a question.
it's FAA Part 101 is what it is. There's a whole thing on size. Basically, I think it was designed that if it was smaller than a bird ingestion, that was allowable. If I recall the history of why it was done.
I have a question on your balloon size. What was your calculable max weight that you would be able to fly with?
I guess we never looked at the max weight. I guess we were always just looking at the minimum weight. If at launch, if you had 10 grams of free lift, trying to calculate in my head. I'm really unsure. We
Well,
always just look at the
the
minimum.
reason I ask that is, as a pilot, you always look at, what your aircraft is able to carry. And
Mhm.
you figure your fuel load, your weight load, and everything else based on that, and your density altitude you're going to be flying at. So that's the reason I'm asking that question. You were always going minimums. If you could have increased your antenna size and and gauge or a couple other things and still been well under your max load weight, wouldn't that have been better for your some of your
Well,
problems that you encountered?
I guess the whole issue was when you add weight of any type, you're going to decrease altitude. And our whole goal up here in our goals at the beginning of the semester design approach was to maximize our cruising altitude. And any type of weight in general, we wanted to minimize. And I guess that's what we were looking at mainly.
No, that makes perfect sense. I was just looking at, if you had calculated that weight and done any density altitude studies.
We did studies that if we added weight, like if we were to do the 2 solar panel configuration, yeah, it did double the weight. It didn't really change the altitude too much. Like it was about 500 feet. The main thing that we were concerned about there was the amount of parts that one could fail with the diodes or something like that. But we did look at okay, let's go with a stiffer stick to hold up the solar panel, and it wouldn't change it that much. So we would just minimize the weight as best we could, but the stick was one thing that we were like, okay, well, we're gonna have to add the extra weight because it really doesn't make too much of a difference. And what I just said about next year was the difference between 16 grams and 9 grams in a tracker does make a difference of like 2,000 feet, but it's not worth it to put all the time into it versus just building a bigger balloon.
And
Understandable.
for those of us who are gram challenged, a gram is the equivalent of a paper clip. So you're talking the 16 paper clips is what their weight is.
And we started at the beginning of the semester. So at the beginning of our semester, we started, our first tracker was 27, and then it dropped to like 21, and it was 17, and the fourth launch was 16.66. So we changed by 10 grams, which is about like 2,000 feet, 1,000 feet.
I have a question about your balloon material.
Okay.
Yes, the balloon material you use to make your balloons, is it designed for balloon making, or is it repurposed from a material made for something else?
So the website we got it from was something called, I think it was like Fluffy. It was the same one that Tom W5KUB was using, and it is designed to make balloons. It's designed to make mainly party balloons, but they also had like the Hindenburg, like somebody made a Hindenburg out of their material. But I don't think they knew people like us were going to send it up to 60,000 feet and are trying to put it under extreme pressure, or not extreme pressure, but pressure over time.
Did you try filling it with smoke or something to see if you could figure out where the leaks were coming from?
We did not fill it with smoke. At first we were just trying to I guess just hear it. And we did not fill it with smoke. But we just kept on. We would patch one hole, we would patch one hole, we'd patch one hole. And we eventually got to where we had 10 or 12 different patches, and we were kind of getting frustrated.
Can I offer a suggestion?
But that's a really good idea. But yes.
For the next time or next set of students, mix a soap water solution in a spray bottle and just spray it on the balloon, and wherever it has an air leak, it'll start bubbling.
Oh yeah, that is nice. We should have done that.
Film.fluffyscarsdale.com is in case you want to build your own.
Since the balloon material, this new balloon is new information, even for me. Do you think all the leak issues were with the seals, or did you find any pinholes in the material?
We found pinholes in the material from, I guess, when it was like just sent to us. We found a couple at the start, and then, but they're really hard to see. They're really tiny. And then I do think there was a seal issue too, because it's just so much material and it's so long that there's got to be somewhere in there that I guess it isn't sealing correct.
Or in a manufacturing process. And I don't know that, you know, Tom Medlin was complaining that it was the sand, like you said. And if you can't poke a pin through it, I don't know what, maybe he hadn't considered faulty material. I'll send him a message and see what his question is on that, or his answer is on that. But that's
That's what I was thinking about.
That's
it
good
in the
to know.
manufacturing process, if they had some kind of electrostatic buildup that was punching these little holes in it or something.
Yeah.
That's why I wanted to know if it was designed for balloon making or if it was repurposed from some other
material.
Yes.
Yeah, you might try just a different vendor of similar stuff in the future. That'd be neat.
That'd be a good idea.
Yeah.
I like the soap idea the most, or the smoke. That's a really good idea. That's something I'll put it down on my like senior exit paper.
Question, please, Vincent. Back to the antenna thing. If I understood you, you've got two on each one. One is 1 meter long and the other is 10 meters long. And you use very small wire. I see this thing flailing around up in the air like crazy, maybe coming in contact with each other. That couldn't be too good.
So we would let the whisper dangle, but we would so after the first 2 launches, we were kind of concerned about that. Dr. Hayes told us that there might be interference because they're just so close, the 2 wires, because we kind of noticed that our gain on our APRS was kind of going down after a few days. It was like a perfect, or is it gain? Something was messed up. Like the signals weren't great. The strength of the signals weren't great. And he said that the wires might be crossing. So right here on this board, this is where the APRS will come out, and this is where the whisper, I guess, right here. Yeah, APRS and whisper. And we would actually take the APRS and put it up on this stick and then let it dangle off. And when we were kind of just like trying to really make him just touch or entangle themselves, we just couldn't. So after we did that, and it worked, like we still got packets out just fine.
Okay.
And also that idea you had of using kind of that more rigid guitar string might be really something worth looking at for the lighter and shorter APRS antenna, I think.
Well, the high E string on a guitar would be fairly stiff, and yet very small, and that would probably do well for the short antenna.
Bill makes cigar box guitars, so that's his question.
That would definitely be something that I feel like next Capstone group should work with and look at, because maybe what if one of our balloons is up there and we just don't even know? Maybe it did snap, or maybe it did entangle. But
okay.
Speaking of the wire, particularly on the longer one, did you have issues with it wanting to curl up?
It never tried to curl. It never. It would only snap when you really tugged on it. But the one that there was one that went straight up, one that went straight down. This one, there was no tension on it because the fishing line, it was glued to the fishing line, and the fishing line tied off to the balloon. But no, it never curled up. I didn't even think about that. I guess it just never happened to us. But yeah, it was pretty malleable.
Other questions for our presenters?
I had a question. I had a phone call there, so I missed a little bit here, but I was curious about those wires. missed out on part of the conversation about the wires hanging down. Do you think it'd be possible to maybe iron like one of the longer wires into the seam of the balloon when you're manufacturing the balloon, and that would give it support away from the other wire?
That'd actually be a pretty good idea. That would be nice. Yeah, I wasn't even thinking about that because currently how we have the configuration is we have a fishing line that goes up, and then along the fishing line we have little tie offs, so there's never tension in that wire. But then we're kind of relying on super glue and like tape to hold 5 meters worth of wire, which it may be up there with the high winds, because it was our balloon along this trail was getting up to, I think our peak, I can't remember what our peak was. It was like 120 or something like that miles an hour. I can't remember if Eric or Two or Amber remember.
Sounds
It was
about
like
right,
100, yeah, somewhere in there. But I did think about like, I wonder if it's actually holding up, or did our ground wire disconnect from our fishing line, and was it also just kind of laying flat down? But when we were discussing with Tom, he said he would just tie it or glue it or tape it, and he said he never had any issue with it.
That he knows about.
Yeah, that he knows about. So yeah, if we manufacture our own balloon, because you wouldn't have to have tension in it, you could just give it some slack.
One
that could be
challenge on
good.
that though is that the balloons are metallized, usually to help
yeah, they
steer.
are.
So that would actually interact with your antenna, that super thin metal coating on the balloon material. Unless you went with a different material, then yeah, no big deal.
Use the balloon as a radiator.
Yeah.
But then you also have to consider,
where were you?
There also, if you're using a 36 gauge wire, if you hung a 1 or 2 gram weight at the bottom of it, just a 1 gram weight, it would keep it taut and stretched out.
They were always flying pretty vertical. I don't know
Yeah.
that 36 gauge just didn't wrap up.
Yeah, it really doesn't. I guess
I hadn't thought about a radiating balloon. That would be a good one for the next one.
I think the students brought that up, but then it gets a little bit more risky whenever you consider the balloons are filled with hydrogen. You'd hate to get a voltage spike or a spark or something and light one off.
Yeah, details.
Look at that! Look at the flash.
But we are trying to send off one more balloon. I think we're just gonna have to go with the foils. I think we're gonna try to make one more big one, maybe a little bit smaller, maybe like 10 feet or something a little bit more manageable, just because the logistics of trying to fill the balloon is kind of crazy, and I think we're kind of running out of material. Because I think we kind of Hail Married it because we had to use 24 feet worth of the material to make, or 32 feet worth of the material to make that 16-foot long balloon. So worst comes to worst, we'll just send off like this 4th launch a foil balloon, but these only get to like 30,000 feet, so that's the whole issue with them. But they're really cheap. They're like $2 a balloon, $4 a balloon versus the SBS 13, which is like 160. So if I was like a school, or I guess next year's Capstone group, if they just want to send one off, I would recommend doing the foil balloons if they know they have good weather, because people online say the foil balloons just do as well as the SBS 13s. Yeah, they don't get to the height requirement, but the SBS 13, like, they're probably, if it's going to hit a storm, they'll probably both hit the storm.
Do your foil balloons say happy birthday on them?
I wish.
The paint would be wasted weight.
Yeah. Minimize it everywhere.
You can attach an NTS message to them, Mark.
Use it for an NTS repeater. That's what we should do. That's cool.
Yeah, I could see, cloud to cloud lightning, taking it down pretty easy.
And if you want to get involved, if anybody else wants to get involved, those little trackers are available. Like they're 100, like you said, $115. And I've got one sitting right here that will talk on whisper and 2 meters. So if you want to play with them, they're kind of fun toy to play with. They program up like an Arduino, and you can put your call sign in them and do all kinds of cool stuff.
Yeah, they also sell a $100 one, but it doesn't have the whisper mode, which I feel like the whisper mode was really cool. So I think it's definitely worth the extra little splurge for the whisper mode.
Well, thank you guys. I appreciate that. That's I hope you all had fun.
Thank you. Yeah. Thanks for all the help this semester. Thanks for having us too. It was fun to talk about our capstone project, not just send a video into a bunch of judges and never hear about it again.
Yeah. The you think you guys are going to continue on with your amateur radio efforts?
I do want to get extra amateur. I think that'd be really nice. I remember I was talking to my job about it. When I was kind of interviewing with them, I told them I was going in for my general, and one of the guys that was interviewing me has this extra amateur, and he like his face like lit up when I told him that I was going for it. And yeah, so maybe it helped. But
I told you.
Yeah.
Good.
Yeah, I plan on going forth on amateur radio stuff over the summer.
Okay.
Just kind of seeing what I can afford to do and mess around with.
Well, if you're staying around Norman, we'll be happy to help, and OU Club would be happy to help, and we'll get you going as you want to do it. If not, let me know, and I'll find somebody wherever you're going to end.
So tell us about your future endeavors. Vincent, you said you've already got a job, and tell us where you're headed.
So I'm going to be going to Edwards Air Force Base out in California. I was yeah, it's out in California.
Skunk Works.
Yeah, I'll be working for Air Force Civilian Services. I'm supposed to be working, and they haven't told me like perfectly. They just said that they can't really tell me that much, other than that I'm going to be working on hypersonic missiles on bombers or fighter aircraft. That's all I was told.
If they put you on an unmarked airplane, I know where you're going.
And then Eric can tell, and and Amber can tell too.
Sure. My plans for once we graduate in these next coming days will be to start at my full-time job in Boeing. I'll stay in Oklahoma City at the Boeing location. For the past year and a half or so, I've been interning with them and doing a lot of aerodynamic analysis on the bombers. It's more of like a support group more than doing anything new, because a lot of OKC is more about modifying the legacy aircraft. So you got to attach multiple antenna, do a lot of repairs and whatnot. And whenever that comes to you, that's the stuff I'll be working on and aerodynamics wise.
Both good jobs.
Amber?
Yeah, I'm still in the process of applying to places and trying to get something good. So looks like I'm going to be hanging around here until I finally until someone picks up.
Yeah.
Yeah, and after my graduation, I will be going for a master program at OU. Yeah, and I'm gonna be hanging around Norman for a while.
Deal.
Very good. Congratulations to all of you.
Thank you. Thank you.
Thank you.
Thank you, guys.
Thank you.
Anyone else with questions or comments for our presenters this morning?